Picture this. A mother walks into a pharmacy to pick up her daughter's medication. The pharmacist hands her the bottle. She goes home, gives her daughter the pills, and 3 days later, that little girl is in the emergency room. What happened? A simple mistake. Wrong dosage on the label. And here's the terrifying part. At 99.9% quality, which sounds pretty good, right? This happens 20,000 times every single year in the United States alone. Let's try another one. 99% quality at an airport means 2 unsafe landings every single day. 99% quality in surgery, 5,000 botched operations per week. Suddenly, 99% doesn't sound so impressive anymore, does it? So what if I told you there's a system that achieves 99.99966% perfection? A methodology so powerful that it saved Motorola from bankruptcy, added $16 billion to GE's bottom line, and has become the secret weapon of every Fortune 500 company on the planet? Welcome to Six Sigma, and by the end of this video, you'll understand why it's worth more than a college degree. Here's what most people get wrong about Six Sigma. They think it's just statistics. But Six Sigma is actually 3 things at once. It's a philosophy about reducing variation. It's a methodology, a step-by-step battle plan. And it's a metric that tells you exactly how good you really are. Let me show you what I mean with something everyone understands. Pizza. Imagine you open a pizza shop. Monday, your pizza comes out burnt. Your customer leaves angry. Tuesday, you overcompensate. Now it's raw in the middle. Another angry customer. Wednesday, you finally nail it. Perfect pizza. But here's the problem. Your reputation is already destroyed. The real enemy here isn't the oven. It's variation. Some days your oven runs at 450 degrees. Other days, 500. This randomness, this chaos, is what Six Sigma was designed to eliminate. See, in statistics, we measure spread using something called standard deviation, or sigma. 1 sigma means lots of variation. 6 sigma means almost none. Here's the magic number. 6 sigma quality means only 3.4 defects per million opportunities. That's not 99% perfection. That's 99.99966% perfection. That's the difference between a good pizza shop and Domino's global empire. But where did this obsession with perfection come from? We need to go back to 1987. Motorola was dying. Japanese competitors were absolutely crushing them. Sony, Panasonic. These companies were producing TVs and radios with defect rates Motorola couldn't even dream of. That's when a Motorola engineer named Bill Smith asked a dangerous question. What if the problem isn't our workers? What if it's our system? He presented a radical idea to CEO Bob Galvin, and on January 15th, 1987, Galvin made a decision that would change manufacturing forever. Galvin sent out a memo to every single Motorola employee. Improve quality 10 times by 1989. 100 times by 1991. Achieve 6 Sigma capability by 1992. The goal? 0 defects in everything. Not just products, everything. Emails, invoices, phone calls, meetings, everything. They didn't just hit the target. They obliterated it. By 1988, Motorola won the first ever Malcolm Baldrige National Quality Award. GE saw what Motorola did and invested $2 billion into their own Six Sigma program. The revolution had begun. So what makes Six Sigma actually work? It's built on 5 unbreakable principles. First, obsess over your customer. Not what you think they want, what they actually tell you. In our pizza shop, this means tracking reviews, complaints, return rates. Your customer defines quality, not you. Second, focus on the process, not people. When pizzas burn, the instinct is to blame the cook. Six Sigma says, map the entire process. Where is the breakdown actually happening? Third, use a structured methodology. You can't fix problems by guessing. Six Sigma gives you a 5-step roadmap called DMAIC. We'll dive deep into this in a minute. That takes you from problem identification to permanent solution. Fourth, build a structured organization. Six Sigma isn't one person's job. You need champions who sponsor projects, black belts who lead them, green belts who support, and team members who execute. Even our pizza shop needs roles. And fifth, wage war on variation. This is the heart of everything. Variation is the silent killer. Your oven shouldn't run at 450 one hour and 500 the next. Six Sigma uses statistical tools to detect variation, trace it to its source, and eliminate it forever. Now let's talk about the engine that makes all of this possible, DMAIC. These 5 letters are the difference between complaining about problems and actually solving them. And we're going to use our pizza shop to show you exactly how it works. Step 1. Define. You can't solve a vague problem. Quality is bad doesn't cut it. In our pizza shop, we're getting complaints. But what's the actual problem? We analyze the data. 15% of pizzas are coming out burnt. That's our defect. Now we define our project. Reduce burnt pizzas from 15% to less than 1% within 90 days. Clear. Measurable. Specific. Tools for this phase. CPIC diagrams to map your process. Voice of customer analysis, flowcharts. Step 2. Measure. You can't improve what you don't measure. We install a temperature probe in our oven. We time every pizza. We record every result. Over 2 weeks, we collect data on 500 pizzas. Tools. Control charts to track performance over time. Measurement system analysis to make sure our thermometer is even accurate. Multivariate analysis to see if the problem happens at specific times of day. Step 3. Analyze. This is where most people fail. They jump to solutions without finding the root cause. We look at our data. Burnt pizzas happen mostly during evening shift. Why? We create a fishbone diagram, also called an Ishikawa diagram, to brainstorm causes. Is it the people? The ingredients? The process? Then we test hypotheses. Turns out, the oven's calibration drifts after running for 4 hours. Bingo. Root cause identified. Step 4. Improve. Now we fix it. We install a new oven controller that auto-calibrates every hour. But we don't stop there. We run a design of experiments to find the optimal temperature, time, and rack position. We perform an FMEA, failure mode and effects analysis, to identify what else could go wrong. We add mistake proofing. The oven beeps if temperature drifts more than 5 degrees. Step 5. Control. This is where most improvement projects die. You fix the problem, and 3 months later, it's back. Six Sigma says, lock in the gains. We create a control plan. We document the new oven settings. We train every employee. We install a dashboard that alerts us if temperature drifts. We run monthly audits. This isn't inspection, this is prevention. We're controlling inputs, not outputs. And here's the result. Burnt pizzas drop from 15% to 0.5%. That's a 97% reduction in defects. Customer satisfaction skyrockets. Revenue increases because fewer pizzas are wasted. And the best part? This methodology works for anything. Manufacturing, healthcare, software, banking. Now, I simplified this for the pizza example, but in the real world, Six Sigma uses serious statistical firepower. Pareto analysis to find the vital few problems. Regression analysis to predict outcomes. Hypothesis testing to validate theories. Design of experiments to optimize multiple variables at once. Statistical process control to maintain perfection. These aren't just buzzwords. These are battle-tested tools that engineers use to solve million-dollar problems. But here's the question every student asks. Who actually does this work? And more importantly, what do they get paid? Six Sigma borrowed its ranking system from martial arts. Here's the hierarchy. White belts and yellow belts know the basics. They're team members. Green belts have real training in statistical tools. They support projects part-time while doing their regular job. Average salary boost? About $75,000. Black belts are full-time problem solvers. They lead major projects. Average salary? $95,000 to $110,000. Master black belts are the sensei. They mentor black belts and oversee entire programs. We're talking $120,000 and up. And at the top, champions. These are executives who sponsor projects and allocate resources. Here's why students should care. A Six Sigma black belt certification can increase your salary by 20 to 40%. Companies like Amazon, Boeing, Toyota, Ford, they're actively recruiting people with these skills. It's not just a certification, it's a career accelerator. But wait, if you've been researching this stuff, you've probably heard another term thrown around, Lean, or Lean Six Sigma. What's the difference? And why do they go together like peanut butter and jelly? Lean is all about speed and eliminating waste. It asks, what are we doing that doesn't add value? Lean identifies 8 types of waste. You can remember them with the acronym TIM Woods. Transportation that's unnecessary. Inventory that's just sitting there. Motion, like workers walking across the factory when tools should be closer. Waiting, overproduction, overprocessing, defects, and underutilized skills. Lean says, cut all of it. Back to our pizza shop. Lean would say, why is the cheese in the back of the kitchen? Move it next to the prep station. Why are we storing 3 days of dough? Order it daily. Why does the cook walk 50 steps per pizza? Redesign the layout. Lean makes you faster. But here's the thing. Lean makes you fast, but not necessarily consistent. Six Sigma makes you consistent, but not necessarily fast. That's why smart companies combine them. Lean removes waste. Six Sigma removes variation. Together, you get speed and quality. That's Lean Six Sigma. And then there's Kaizen, the Japanese philosophy of continuous improvement. While DMAIC is for big projects, Kaizen is for daily micro-improvements. It's the mindset that says, every single person in this organization, from the CEO to the janitor, should be looking for ways to improve every single day. Kaizen uses the PDCA. Cycle, plan, do, check, act. In our pizza shop, this means daily team huddles, where the delivery driver can suggest a better route, and the prep cook can suggest a faster way to slice pepperoni. So here's how it all fits together. Kaizen gives you the mindset of never being satisfied. Lean gives you the tools to move faster. Six Sigma gives you the tools to be more consistent. Combined, they create a culture of relentless improvement. That's why companies that adopt all three don't just improve, they dominate. Remember that pharmacy mistake we talked about at the beginning? That little girl getting the wrong prescription? Here's what Six Sigma did to prevent it. Barcode scanning for every medication, digital cross-checks, standardized workflows, automated alerts if dosage seems wrong. Six Sigma isn't just a set of tools. It's a way of thinking. It's the mindset that says, good enough isn't good enough. We can do better. We will do better. And we'll prove it with data. Whether you're an engineering student, a manager, or an entrepreneur, this is the skill set that separates the good from the legendary. Here's my challenge to you. If you're eager to learn Lean methodology, the 8 wastes, value stream mapping, Kanban systems, comment Lean right now. If we get enough requests, that's the next video. Subscribe to Academic Engineering. We take complex topics and make them actually make sense. And I'll see you in the next one.